All right, I want to get a video out on polynomials for this week for the pre-calc class, and I'm using the software to analyze these things now so we can see the connections between the polynomials and the graph. Now this thing is already in factored form here. If I also make a copy of it and put it in expanded form, well, I don't need two y's in there, but I can have the computer do that for me. Expanded form would look like that. That's not as obvious what it's doing, right? The graph is exactly the same because that's two things in the same, and just in two different forms. Okay, now in expanded form, you can look at it and see it's degree 3. It's going to look kind of like an x cubed thing, 2x cubed, which has this kind of shape to it, right? It starts below, comes up, and then goes on up like an x cubed thing. So this is going to start down here and end up here. But this stuff in between is determined by the details of it. But that first term tells you kind of your long-range behavior. It behaves like 2x cubed. If we looked way out at it, it just has the shape of a cubic function. All right. That was a little extreme there. And the other thing that you can tell from the expanded form of it is that y-intercept is at 40, because when x is 0, all that's left is the 40, so you get a free point out of that. But the factors, the magic thing about polynomials is what happens with these factors. Very important principle with polynomials is the factors are the zeros, right? If you can write it out in factors like this, then it has to be 0 when x is 2. It has to be 0 when x is -4. And with something like this, we're going to get a fraction because this is 0 when x is 5/2. 2.5. So zeros are 2, -4, and 2.5. 2, -4, 2.5. Those are exactly the x-intercepts, or what we call the zeros of the function. And not only do they have to be zeros, but that's the only way you can have a zero, is if you have a factor that goes with it. That's a powerful thing about polynomials. So this one's degree 3. Now the height of it isn't that big a deal. I could shrink this thing down or change the y values, and it doesn't make that much difference. The zeros tell you where it crosses the x-axis, and the only places it can cross the x-axis. So we can tell where it's equal to 0, but we can kind of figure out where it can be above and below 0. Because it has to start down here to be to behave like 2x cubed. It has to start down here. It goes through at that point. It's going to be above, then it's going to be below, then it's going to be above. If I put another 0 in there, a factor like this, well, that's going to be 0 when x is 0. So now we have a factor at x equals 0. Also, this is not the same thing now. So the factors are, I still have the zeros I had before, but I have another 0 here. Now it's behaving like an x to the 4th thing, because this, if I expand it out, is positive x to the 4th thing. So it's going to be going up on both sides of the graph, like x to the 4th does, and you get your zeros, 1, 2, 3, 4. Now, something slightly more interesting can happen with these things. We might get two of these factors that end up exactly the same. You could have the factor x minus 2 in there twice. So that could be written this way. That's awfully close to the other one. So I'm going to change this one while I'm at it also. Now that's at 7/2, and this is a 0 at 2. It still has a 0 at 2, but you see, right near that 0, it's a different behavior, because if it's in there twice, it's like x minus 2 squared. That could be written as just x minus 2 squared. That's the same thing. And so it behaves like an x minus 2 squared. It behaves like a squared function around there. So it's got a 0 at 2, but like a parabola, it just touches that thing and goes back down. That's behaving like an x squared at that 0. At this one, it's behaving like a line. It just goes through. And at this one, it's behaving like a line. It just goes through at 3.5. But when that what they call multiplicity is 2, it's there twice, it behaves like an x squared. There it goes through it and bounces off. If you have multiplicity 3, that's going to behave like an x cubed. It's going to level off hit the 0, does cut through and goes in the other direction with odd multiplicity, but it also has that flat spot right around it. Now we're already up to pretty complicated stuff. You might be thinking, if I have a great big polynomial like that in expanded form, how am I ever going to find all of the factors of it? Because it's not obvious how to factor this thing when we're up to this big. That's going to be a challenge we're going to work on in this chapter. But the nice thing is, if you can draw the graph of it, you can start to tell what some of the factors are. And if you can work the factors out one at a time, then you can factor them out or divide them out. And using division, you can work your way down to smaller and smaller polynomials. We're going to be working on this for a while, but I wanted to get a video out on the implications of this graph and how powerful that is. The idea of the zeros and the multiplicities of this thing. And a little bit about the long-term behavior. I can tell what happens with inequalities on this thing, where this thing is greater than 0 even, because I can tell where it can cross through the 0 thing. So an inequality, if I rearrange the inequality, I just want to copy that again and look at where this is greater than 0. Well, that seems like a crazy inequality to solve, but if you can sketch the graph of the function and tell where those zeros are, the only way it can change from above 0 to below 0 is going through one of those zeros. So you can figure out where it's true and false based on where the zeros are. This is, did I change something on this? This is greater than 0. It's close to 0 right around there, but it's greater than 0 on this side. I'm not getting great graph of it. I don't know why that came out kind of weird. But it's greater than 0 on this side. It changes to below 0 in between those because it has the 0 here and here, so it would be false in between there, and then greater than 0 again. And so we can tell where it's equal to and where it's greater than or equal to 0. That's what we'll be doing on a lab this week, and learning more about how to work out what these factors are as we go through the chapter.